Christmas has come early at the Henry residence. Most of the primary parts for my amplifier that I'm going to build are here. They've arrived a little early. I wasn't really expecting them until later this month. So good on the Chinese shippers. Starting from kind of the input side to the output side, let's start out with the power supply. It is got 70, a plus and minus 70 volt rails. So you're going to have, your AC line coming out this way, power going to the amplifier modules. Let's look at one of these amplifier modules. I've got two of them. They're so pretty. Those are not really heat sinks, although I think they'll work as a heat sink for a little while, but it would get too hot if you tried to drive it at full power with just this little bit of a heat sink out here. These heat sinks are designed to bolt onto a heat sink. It's really not really even a heat sink. It's more like a mounting plate for all of these beautiful transistors. We've got big ones and we've got little ones on there on both sides. This is an L25 amplifier module. I'll just go ahead and say it's probably capable. They're supposed to be capable of 250 watts into 4 ohms. Obviously, there's two of them. Chinese components. All this stuff is Chinese components, but just initial inspection, it looks like it's pretty decent quality. Looks like we've got the input connector is a little hinky dink. It's a little crooked. And then there's a ground right beside it. I imagine that's the speaker ground. The speaker output is here in the middle. Interesting. Then you've got the negative voltage on this side and the positive voltage on this side. This is a speaker protection module that's designed to monitor your AC coming in from the power switch or whatever, and then there's a delay to route the output of the amplifier to the binding posts on the back of the amp. When these amplifiers and these power supplies are powering up and powering down, strange things, or not strange things, but interesting things happen. It could make strange noises, and I don't think it could hurt a speaker, but there could be a pretty loud pop. This is all designed to stop that from getting to your speakers. There might also be some protection going on there. Over here is the audio signal input. This is your volume, this is your bass, this is your treble, this is your subwoofer crossover, this is your loudness. So the RCA will come in, the audio input will come in from the back of the amp through this thing and over to the power module. And like I said, I've been prototyping, and I think I've got it kind of the way I want it. It's sounding pretty good. I've got it. I've been testing it through the little amp there and through the speakers and routing audio over to the sub and all kinds of stuff like that. So hook it all together or fire it up right here on the table and at low volumes test it out. I'm not going to try to push it, right, mainly because we don't have any way to dissipate that kind of heat yet. This really needs to be mounted to some big heat sinks if you want to get it up to its full potential. But all right, wish me luck. I'm gonna go get the fire extinguisher. Box full of junk, old junk. Old non-working computer power supply. Ha ha. I was like, I know why I keep this stuff laying around. Look at all that wire, by the way, for the internals of an amplifier, where you have little jumps that are only a few inches. All that wire is going to come in handy. But look what else I got right here. I got that. I got that. I might even use that. And definitely going to use this. so I'm going to cannibalize this old computer power supply. Quick power supply test. I got it hooked up to this bus bar over here. It has a circuit breaker in it. I was looking at this pinout on here, these wires. It says it has an N. I assume that's for neutral. It has an L and an NC, and if you look at that NC, it literally means, I think, no connection. If you look at the circuit board, there's no trace. I don't know for sure, but I did not connect earth ground to the power supply at all. We'll see what happens. Got the multimeter set up here. Like I said, that has a circuit breaker in it. If anything goes really bad, let's see if I can find. Yeah, here's a fire extinguisher. And then let's see. Pull plug. I wonder if I should break that white thing. We're not going to need a fire extinguisher. We're going to fire this thing up and see what happens. All right, so I'm going to go ahead and throw this switch this switch is in the on position. I'm going to leave it in the on position, I think. I'm going to use this switch over here as the power switch. Here we go. Okay, we got a red happy indicator light over here. So I'm going to now, I don't know how I'm going to set this camera up so you guys can see. I'm going to put my multimeter across the power outputs on the power supply here. The middle one is ground. And then let's see what this one is. Okay, I got 74 volts, negative 74 volts. Over here I got what? Positive 74 volts? Yes, positive 74 volts. Coolio. I think that's all I'm really going to test right now. If I try to get in here and get across these, I might short them out. I need to detune that a little bit. There should be a pot somewhere on here where I can turn that down. All right. So, smoke test passed for the power supply. Okay, smoke test number 2. The power supply is now wired to the amplifier modules, and there's no trim pot on the power supply. I can't reduce it from 74 down to 70. And the amplifier modules say they're 70, so I don't know. Maybe when maybe with no load, it was floating up to 74. I don't know. I'm gonna push the button and see if I get any smoke. And if there's no smoke, then maybe I'll measure and the voltages across the amplifier modules, and maybe see if it's dropped from 74 down to 70. Here we go. Power LED on the power supply did not come on, so oh, it's not plugged in. Hang on. All right, I got it plugged in this time. And 3, 2, 1. Wait, hang on. Here we go. All right, the light on the power supply is on. I'm going to take some voltage measurements across the amplifier to see if it's dropped to 70 volts now that it's got a load on it. Yeah, it's 69. I kind of thought that might happen once it got a load on it. So I got negative 69.2 on one side and 69 on the other. I'm digging it. Looking at smoke test number 3, I now have the speaker protection module wired to the amplifier and the AC, I guess you'd call that signal, the signal that it uses to know whether or not it's got power. The power supply light should come on and we should hear a click. We should hear these relays engage. Alright, hitting the switch. Okay, I just heard them click. Yep, so right now I should be able to get continuity between the amplifier inside and the amplifier outside. I'll go off camera and check that. So far, so good. Alright, smoke test number 4. We have not really added a whole lot. I mean, I've just got wires coming from the speaker module, and I've got wires coming from the DSP. The DSP is going to get power from a brick for now. I'm just going to fire this up and make sure nothing bad happens. Then after that, I'll hook the speakers up. Got a power supply light. Okay. The protection module kicked in. So far so good. Next test should be a little more interesting. Smoke test number 5. The amplifier is under load. No input signal. So we just want to make sure that while it's we have dummy loads hooked up to the amplifier output. It just kicked on. I got the 2 blue LEDs and nothing's getting hot. It, you know, with no signal, no input signal, it shouldn't be trying to produce any power. Shouldn't be, and it's no smoking. You know, no smoke is good smoke. The next test should be a little more interesting. I'm going to hook up the scope and apply a small signal and see if I get a signal at the speaker outputs. The scope is hooked to the outputs. 1 kilohertz. And then we're going to do the single repeat. So it'll repeat that track over and over. The laptop volume, it changes when I plug it in here. Hang on. Laptop volume is way down. The DSP volume is also way down over here on in the little pot. But I'm going to spark it up and the scope probes are on times 10. Yeesh. What is that? 2 volts per division. That looks like a lot of noise. I'm going to try it again now. I got a lot of noise, and I don't know if the noise really affects the amplifier so much as it affects the oscilloscope. But now I've got the ground. I've got a ground oscillation transformer in the signal path between the DSP and the amplifier. I don't think I'm going to have to do this in the real build. I don't understand for sure why I need to do it. Well, let's find out if I need to do it. I'm getting ready to. Let me turn the volume down on the DSP. Alright, now let's fire up the amplifier. Oh, you don't like that. We're getting a flash on the scope, and the protection circuit was engaging the speakers and then immediately kicking them off. So crazy times. Let's see. Day 2 of the amplifier build. I have run into an issue, and I'm trying to figure out. Tried a few things, haven't had any success yet. Good news is the amplifier does work. It amplifies. I did hook it up to the speakers, and maybe I'll do that. Tag it onto this video. Makes really good power. I can only push it a very small amount and for a very short amount of time, because we are not dissipating a whole lot of heat. These things get they get so hot you can't touch them pretty quickly. My problem is I've got a terrible noise floor. I can't figure out where it's coming from. The inputs to the amplifiers are very sensitive to the point where I can't get in a clean signal. That the input sensitivity is 0.6 volts. What happens is when you crank it up, it creates such a huge noise. It creates so much noise that the protection circuitry, I think, kicks in and shuts it off. If it had been hooked up to a speaker when I did that, I probably would have blown speakers. I've tried flipping them around. I've tried a different cable, because the cable that I have, or I've had hooked up, the one I have hooked up on this side now, it's the same as this one. I bought this thinking that I would be able to, basically, it was cheap, and I'd be able to cannibalize it, assuming when I saw it on Amazon that, this cable inside of here would be shielded, but no. It's just a 2-wire, which is kind of cheesy and disappointing. But I do have another one here. See, this one's proper. It does wrap. I would call this shielded. So I'm gonna get in the middle of it, right? I'm gonna get in here on the breadboard and see if I can condition the input signal. I've tried to use an isolation transformer, and it did not like that either. I'm going to try to condition the input. The first thing I'm going to do is attenuate it, for sure. So real quick, I'll show you what I'm talking about. I've got the scope up here. I hope. It's been a while since yeah, it looks like it's okay. So I'm going to turn it on. Yeah, that is all noise floor. It does amplify. I'm going to bring up the volume on the DSP here. So see, it is amplifying, and it don't take much for this thing to get loud. But I'll maybe hook up the speakers in a little while. It sounds good. The part of the signal, or the part of the part of the playback that's over top of the noise floor, sounds good. I conditioned the input by putting a small RF size cap from I guess you would call it the positive side to the ground, and then a limiting resistor over to the input. Basically just kind of, yeah, limiting the voltage on the input of the power amplifier. It's really helped it a lot. It doesn't get hot like it did.
Test.
It's like raspy. It's a little bit of a raspy sound. It's just not quite. It's just not. It's not clean, and I don't understand why. Well, I never really believed in burn-in. I don't know. I guess it's possible that a piece of electronic gear, we're talking about transistors, they need to get hot in order for them to reach their operating. Yeah, you know what? I don't know. I'm not sure why, but it sounds pretty good now. I can tell. I'm letting it cool off. Yeah, it's pretty cool now. I can tell that, in my opinion, this amplifier, because it has all the makings of something pretty special. It's crazy powerful, and it's got really. I think it feels like it's got really good detail. It's got good highs, and plenty of power to make bass. You know, that's what you need to make bass, is power. So let's hit the button here and so if that was a volume control, that's all the way down. That would be about half. More than I think I want to try to pump through these little old. These C notes, they can handle some power though. I can hold it. I can kind of hold it, but it gets hot fast. Got to get some heat dissipation going. So I am. I'm feeling pretty good about this rig. Obviously, the next steps are going to be to try to figure out how to get it into a case and get some heat sinks hooked up to it and keep it cool and get it all, you know, switches and knobs and all that great stuff. But I'm pretty jazzed, pretty pumped up. Sounds good. I dejunked the table real quick. Want to go through how this is all put together. So on the power supply side, you've got your AC cord, right, coming into here. Out the back side of that, it goes to the power supply. Now here kind of joined in that joint, or that connection, black and white, coming over to the speaker protection module. This is how it senses that power's been applied, and then after a delay of time, it'll engage the speakers. On the other side of the power supply, you've got a positive 70 volt and a negative 70 volt. That's what a lot of this wires are, that and the ground. So the ground here is doubled up. These two are both coming out of the power supply ground. One's going to the left side and one's going to the right side. This one's also doubled up. Right? You see how they're doubled up? The gray is doubled up here. The gray is the positive, and the green is the negative. Color coding is a little poor, but that's the wire that I had. Now, on the speaker side, so that's got the amplifiers powered, and on the speaker side, if you look here at the ground is going in and the ground is coming out for the speaker side and coming over here. Same on this other side, right? You've got a ground going in and a ground coming out, coming over here on the speaker side, and then here, and here, that's the speaker positive. Right, so that's the four here, right? You got two grounds and two positives coming into the speaker protection module. And that's all the wiring for the, it looks like kind of a mess here, but it's really kind of simple. Well, there's also two more. So here, right, this is an RCA. This is like there's a center conductor, and then there's a shield going around the center conductor. And if you can see down in there, the copper color right down in there, that's the shield, and the white is the center conductor. Over on this side, it's red. So these are the input signal. This is the input signal going to the amplifier modules, and where most of my problems were coming from. Down here, there's a little rat's nest for that solution. But let's continue on. The speaker to the protection module, it really just kind of jumps through those two big blue relays and comes out on the other side, right? The two grounds, two positives, coming out here to the binding posts. And I first had spades. I think that's the spade. I had the female spade clipped on there, and they didn't make a very good connection. They were a little shaky, so I just soldered that on. I feel like this connection's pretty solid, but this connection here was shaky. Speaker wire. All right, now let's look at this input mess over here. This cable is power coming from a regular USB brick to power this digital signal processor. Alright, so from the laptop, we're coming out of the headphone jack, going through these RCAs over to the input of the DSP. The output of the DSP coming over to the amplifier modules. Power for the DSP is coming in here. This big fat cable, that's a signal cable that's for the subwoofer. And I don't have to have that, but I've got it hooked up right now. I was doing some tests. So that runs way over there to that subwoofer over there. Now, this is power and ground coming from the DSP in order to supply voltages for these signals. I've got switches in here that control functions of the DSP. All we're really doing, these cables are coming up to GPIO inputs on the DSP, and when I push a button, it makes the DSP do something. Now, down here, from the output of the DSP, right, we're coming into the breadboard. Then from the breadboard, we're going over to the amp. I don't know how useful this is too, but you know, I complained about, I had so much noise. The main thing I did to get this thing usable, really, sounding decent, was just basically to attenuate with a resistor the output of the DSP going into the amplifier modules, and that pretty much covers it. It's not really all that complicated. Obviously, when you're messing with this kind of stuff, you know, the output of the power supply is 70 volts DC. If you were to get across, if you got one finger on the negative 70 and another finger on the positive 70, I don't know, it might knock you down. It would definitely hurt. And probably even really more dangerous is the bare wire, like here, right here is bare wire AC, right? You get across one of them and you're going to get the shock that you get from the wall socket. And if you've never gotten shocked by a wall socket, most people have gotten shocked by a wall socket, haven't they? I would think so. If you haven't, you probably haven't lived. These amplifier modules are produced by LJM. LJM is a guy, is it a person, man or woman, who knows? Is it a company? I don't know. It's an email address. It's getting quite a bit of notoriety. I mean, there's Michael Beanie really loves the L25. There's an L25. Michael Beanie loves the L15. There's an L15. I think there's an L10. There's an L12. 10's 100 watts. 12 is 120 watts. 15's 150 watts. The one I got is the 25, the L25. So I've dubbed my amplifier L25DSP. The LJM amplifier modules, I mean, you can buy them on Amazon, and definitely buy them on eBay. They take a little while to get here, right, because they're shipped from China. The quality seems to be pretty good, and the specifications, the harmonic distortion is really low. I'm fairly sure this is a push-pull, sort of an AB design, but I can't find a schematic for it. Someone has reverse engineered some of the other LJM amplifier modules, and there are some schematics floating around for them. Some of them use MOSFETs. These use transistors. I chose this amplifier, the L25, because it's a push-pull I assume it's push-pull. It's got to be. I chose it because it is transistors and not MOSFETs. There's a slight opinion around that maybe MOSFETs are really made for switching more so than smooth, linear-ish, right, amplification. But, you know, there's a lot of people making really great amplifiers with MOSFETs, so I definitely wouldn't let you stop that. I wouldn't let that stop you from getting a board that's based on MOSFETs instead of transistors. These transistors are relatively famous for the ones on this board for high-quality amplification, high-quality amplifiers for many, many years, maybe even decades. You know, it's not Class D amplification. It's somewhat inefficient, not as inefficient as a Class A, right? Class A is basically your wave is all in the area of one sort of transistor. Class AB, the wave crosses over down to another transistor, so you've got a transistor to amplify the positive side and another one to amplify the negative side. The AB's setup is more efficient. It's not as efficient as Class D. Class D is a whole nother sort of technology. And the Class AB has you have to be cognizant. You have to look out for what they call crossover distortion. That's not the same thing as crosstalk. Okay, crosstalk would be interference that bleeds into channel A from channel B. That would be crosstalk interference. Crossover distortion is if you don't have the currents set correctly on the transistors. When you pass from the positive side down to the negative side, you get a little squirrely, a little wiggle. Michael Beanie is really into that and figuring all that out. He's got that, I think it's the L15 or the L12 or both. He's got that thing tuned in to where it's pretty much perfect. You have to make a mod to do that. You have to like go in and find a transistor, or not transistor, but a resistor that you can then maybe either replace or shunt across with a trim pot in order to get fine control over the, I think it's called the quiescent current. This L25 doesn't have a adjustment like that, and there's nothing, no one's done the research to figure out how to give it that adjustment. So I'm just running it the way it is. So yeah, that's kind of some, and then the decision about the digital signal processing. I mean, I think you got to have tone controls. And they say, you know, it colors the sound. You know, you want the perfect sound. You want to bring the recording digitally to your ears in its purest form. And to that I say, any recording needs to be adjusted. Any recording may need to be tonally adjusted for your room, for your speakers, for your ear. To deny yourself that ability seems silly. Now, there's a couple of ways to do it, right? You could add tone controls in your analog world. That's after, right, the digital signal's been converted to analog. You know, you can use band pass or band, you know, high pass, low pass filtration controlled with a resistor that, you know, if you put a resistor into your like a second order cross, you can think of it as a crossover, right? But you can control it because there's a pot that you can turn that will vary the frequency. You know, that type of tone control might color the music in an undesirable way. It might, if you're not careful, you could introduce things into the analog signal path. Another way to do it is through actively, right, where you would take the signal and you would run it through an op amp, and then the op amp you'd have control over, maybe, I'm not sure. There's ways to have really good sounding tone controls, and then there's average sounding tone controls, and then there's probably tone controls that add more color than they do produce good sound or make it. But you got to have tunability. So the reason I went away from tuning it in the analog world to tuning it in the digital world is to eliminate undesirable coloration. That was my main goal. I am not going to have an amplifier that I can't control the tonality of it. It doesn't make any sense to me. I guess I could have an amplifier that's direct, and this one I'm going to have a direct couple feature on this. You're going to have a way to bypass the DSP altogether. And then, you know, if you have your tone controls, maybe you have an equalization program in your digital world on your laptop or something like that. Personally, I don't see any point in. Well, I mean, you could listen to something that doesn't have tone controls, but without tone controls, you're limiting yourself in a way that's. I mean, you could never probably really get it to sound as good as it can sound. You've got to be able to tune for the speaker, for the room, for the individual's ears. I mean, No recording. All recordings are not created equal either. I mean, some recordings need help. And that's just the way it is. All right, well, I've ranted about that enough. I think it's, I'm pretty pleased with the build quality of these amplifier modules. I'm pleased with the build quality of the protection circuit. It's nice, it's good, and it's detected some problems and stopped me, I think, from blowing stuff up. So that's great. It's exactly what it's for, right? And then the power supply, very powerful. I haven't measured yet. I need to make some measurements after I get it all put together, get it under load, make sure that the power supply is, you know, not dipping. When there's a strong bass, I want to make sure that, you know, you don't see the pull on the rails. It is a switch mode power supply, which, if you think about how they work, the way you're able to get that much power out of them without having a huge a huge transformer, is what they do is they speed it up, right? A big transformer is made to produce voltages at 60 hertz. What these switch mode power supplies do is they bring your 60 hertz in and they run the frequency up, probably, I don't know how high, maybe 10 kilohertz, maybe 100 kilohertz. I'm not sure how fast they go. When you connect a transformer to that, you don't have to have as big of a transformer, and you can still get the same amount of power out on the output side. I know that's a really terrible explanation of how switch mode power supplies work. You know, this one looks to me like it's really well built. The amplifiers have great detail. The power supply is very powerful. The protection module does its job. So far, I'm very pleased, and I'm going to continue to build. I got some heat sinks ordered, and from there we'll, you know, lay it out, plan it out, and build it out. And until they're here, I'll listen to it at low levels and heat these little heat risers, whatever they are, not heat sinks, they're heat plates. I'll heat them up, and then we'll turn it down and let them cool off. All right. Thank you for watching. What the heck is wrong? What the heck is wrong with this thing? Man, I can't get it somewhere. Hang on, let me do it. Oh. Alright, let's see. Pull that out of there. What? What's wrong with it? I don't see what. Ah!